Hello again, class. Dr. Yeager here, finishing up chapter 11. Uh, we, we, we ended up talking about mass wasting. And before we go through the four major types of mass wasting, just wanted to touch on a few other things that are important in determining how mass wasting happens. We talked about angle of repose last time. Remember, that's just that angle at which I look like I'm doing a karate chop. It's just that angle at which a common or that a material can stay at rest, and different materials have different angles of repose. We talked about sand last time. Think about something like gravel. Can you stack up gravel at a higher pitch than you could with sand? Yeah, of course you could. And so if you have a slope or a hillside that is primarily made up of gravel or that thick, coarse conglomerate type of soil, um, that 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 slope is going to be able to exist at a steeper slope than something that's sandy. And if because of erosion or some sort of breakdown, a sandy slope becomes too steep, there's going to be some sort of mass movement there to correct that angle of repose. A lot of times, if we get water acting as a lubricant between those particles in the ground, water is an excellent lubricant, and it can cause that rock material to give. It can cause those particles to move and initiate some sort of mass movement. Obviously, soil that has a lot of clay in it, when we add water through precipitation, clay can become hyper lubricated, can become really, really slick, and slopes that have a lot of clay in them can see very quick mass movement. There's something called quick clays in the northern latitudes. Quick clays are very old soils that were lifted up through plate tectonics. Of interest to us here, talking about mass wasting, is that when quick clays have a lot of stress put on them, that could be through something like a landslide or a jolt of energy like an earthquake. Quick clays sort of begin behaving as a liquid, and so you'll go from having solid ground to having ground moving downslope like a liquid, which would be really, really terrifying. And then finally, in places where the ground is frozen much of the year, there are mass wasting events that happen. What we call these solifluction, or we call these mass wastings that are associated with permafrost, when the ground goes from being frozen to melting during the warm months. Um, that type of mass wasting basically turns the ground into a very, very slow moving river, as any place that isn't perfectly level begins sort of creeping down slope because of the effect of gravity. So as I go through these four mass wasting types, what I want you to do is I want you to refer back to this chart right here. This chart is a good way to conceptualize mass wastings. We're going to talk about falls, slides, flows, and creep. And so all of those are represented here. There are even like there's earth flows and mud flows. We're just going to talk about flows in general. We're just going to talk about slides in general. But what's important is they tell you how fast each one of these are. So the mass movements that are over here happen really fast. These ones over here happen really slow. Okay, I want you to know that. And they also show you which ones need a lot of moisture to happen and which ones do not. So these ones up here need moisture to happen. These ones down here do not. Okay, so as you're studying, as you're reading about these, make sure to refer back to that chart, okay? So the first mass wasting event I want to talk about is the fastest. or one of the fastest, and it is just called fall. It's about the easiest name you could imagine. Fall happens when a weathered piece of rock, I'll let you guess, falls, right? It falls down. That's the name, fall. Um, so this picture is a great example of fall, or rock fall in this case, because what is falling are rocks. You can see the color of this material down here, and on this escarpment over here, you've got two different kinds of two different colors of rock. You've got this dark rock right along here, and you've got this lighter rock up on top. A lot of this, most of this rock down here, the color is the same as this color up here. So I would ask you the question, where did all this stuff come from? Well, all this stuff came from up here. And you can tell not only by the color, but you can also tell by where there are areas up here on this upper layer of rock where there are sort of voids, right? You can tell by this V shape right here and this V shape over here. There used to be stuff there. Well, where did that stuff go? Well, over time it weathered through mechanical, chemical, or biological weathering, and it broke off. And it might have sat there for a while. It might have sat there for a long time. Who knows? And maybe at some point a bird came and landed on it, or a raindrop hit it, or an earthquake shook it, or something, and it fell down. And it fell down and formed these big cones down here. Once this weathered material breaks off, we call it talus. So any weathered rock that is broken apart and has been subjected to mass wasting is called talus. You may see it called scree in some places. They mean the same thing. So in a situation like this, these big pyramids that pile up down here are called talus cones. When you get many talus, it still looks kind of like a cone, right? An upside down ice cream cone. When you get many talus cones growing together, you call that a talus apron, because they sort of grow into each other and they look like an apron, as if the as if the mountain was baking cookies or something. Over time, the tops of the mountains wear down and these talus cones grow up. Okay, so the talus cones get steeper. The tops of the mountains get weathered down. Rockfall happens really, really fast, and rockfall does not need any moisture at all to happen, right? So it can happen at dry, and it happens really, really fast. The next one of these mass wastings I want to talk about is called slide. So we've heard about landslides. Obviously, that's a type of slide. Landslides, again, are fast, but landslides are typically not as fast as fall. Landslides are slope failures that happen sometimes because of the added weight of precipitation, or sometimes because of a jolt of energy from an earthquake. Excuse me. Now you'll have to, that presents a question. If I say that mass wastings like slide can sometimes be caused by precipitation, on this chart back here, it shows that slides are fairly dry, right? They're not up here with the mass wastings that are caused by a great deal of precipitation. Well, it's not, although any moisture added to a slope is going to cause an increase in lubrication, which is going to make it more easy for the slope to give way. With slides, it's usually more of a situation where it's the added weight of all the water that causes the slope to give way. Of course, the lubrication helps, but it's the added weight of the moisture itself more so than the lubrication of the particles from the precipitation. Okay, so there is some moisture required, but it doesn't require a great deal, and slides can happen really, really quickly. Third of these I want to talk about is called flow. Now, if we want to compare flow and slides, well, just the two words tell you which one requires more moisture, right? Liquids flow. Baseball players slide. Okay, baseball players are not liquid. Um, Rivers flow. Okay, so if you're just comparing in your head, okay, which ones of these are require moisture, which ones don't? That's a good way to think about it. Obviously, flows are slope failures that generally happen because there's a great deal of moisture. That could be snow that falls during the winter and then melts in the spring, or it can happen from a great deal of rain that happens in a short time. Any one of these things that happens causes a slope to give way. Would be called a flow. These things become really, really dangerous because as that slope gives way, it's a fast moving uh, mass movement, and that slope that's failing can pick up lots and lots of things. Obviously, it's going to take a great deal of soil with it, and so these mass movements can become really fast moving rivers filled with stuff that can be obviously really dangerous for anything in its path. But if you just look at these pictures, obviously there's a great deal of liquid associated here. But even if you look over here, so there was initially this slope failure right here. It was where the original slope is, you can sort of tell. And then this slope came down through here, and it came down towards this little stream here. If you look at the way this material, which used to be up here, has dried down over the course here, you can almost tell it has a flowing quality as it came down the slope there. So there's a great deal of water involved in that. The last one of these I want to talk about is the slowest of all, and it's called creep. Creep is the slowest of all mass movements. It is not dangerous. It can happen with or without water, but it does not need any water at all. It's just like fall. It will happen it'll happen in dry areas. And creep happens everywhere that the ground isn't perfectly flat, which is essentially everywhere. Any place the ground isn't perfectly flat, gravity is working on bringing those soil particles down, just like it brings water down in a rainstorm. Just because it happens really slowly doesn't mean that it's not happening. In particular, creep happens where where there's freezing temperatures, and when it gets cold at night, the particles get closer together. When it thaws out the next day, they get farther apart. Over time, that's going to cause that soil to sort of step down and step down. It's really hard to see where slope is happening, even though it's happening every place. If you're ever driving along a country road and you see an old mailbox or an old telephone pole that's on the side of a hill, or the side of even sort of out of the drainage ditches on the side of the road, if you see an old mailbox, you know that farmer, when he built that mailbox, it was straight up and down, because that's how farmers build things. But over the course of 40, 50, 60 years, if that mailbox slowly kind of tipped over, just gently, that's because the slope where that mailbox was built over time is going down because of gravity. So that's just pulling that thing down. Fence posts, like I said, telephone poles, mailboxes, those are all evidence of creep. Solifluction is a particular kind of creep that happens in cold weather environments where there's freezing and thawing. And solifluction is interesting because it gives you these easy to see lobes, kind of like in this picture here, where the hill is coming down this way and the topsoil is just slowly flowing down there. Creep doesn't give you anything like that. If you want to find creep, you've got to look for it with those mailboxes and things like that. Okay, I'm going to stop there. I'm going to stop with chapter 11. We'll tackle chapter 12 next, and we'll see you then. Have a great day.